Hello students, welcome to the channel. In this video, we'll solve the third reading passage of the October 2020 US SAT. This is a paired science passage. Passage 1 is adapted from cloud seeding, not effective at producing rain as once thought, new research shows. Passage 2 is adapted from Janet Pelly, does cloud seeding really work? Passage 1. In many areas of the world, including California's Mojave Desert, rain is a precious and rare resource. To encourage rainfall, scientists use cloud seeding, a weather modification process designed to increase precipitation amounts by dispersing chemicals into the clouds. But research now reveals that the common practice of cloud seeding with materials such as silver oxide and frozen carbon dioxide may not be as effective as it has been hoped. In the most comprehensive reassessment of the effects of cloud seeding over the past 50 years, new findings from Professor Pinhas Alpert, Professor Zev Levin, and Dr. Noam Halfon of Tel Aviv University's Department of Geophysics and Planetary Sciences have dispelled the notion that cloud seeding is an effective mechanism for precipitation enhancement. So this passage begins by speaking about the process of cloud seeding, which is to induce rain by dispersing chemicals into the clouds, and how recent research has shown that it is not as effective as was once hoped. During the course of his study, Professor Albert and his colleagues looked over 50 years worth of data on cloud seeding, with an emphasis on rainfall amounts in a target area over the Sea of Galilee in the north of Israel. The research team used a comprehensive rainfall database and compared statistics from periods of seeding and non-seeding, as well as amounts of precipitation in the adjacent non-seeded areas. By comparing rainfall statistics with periods of seeding, we were able to show that increments of rainfall happened by chance, says Professor Albert. For the first time, we were able to explain the increases in rainfall through changing weather patterns instead of the use of cloud seeding. Most notable was a 6-year period of increased rainfall, originally thought to be a product of successful cloud seeding. Professor Albert and his fellow researchers showed that this increase corresponded with a specific type of cyclone that is consistent with increased rainfall over the mountainous regions. They observed a similarly significant rain enhancement over the Judean Mountains, an area which was not subject to seeding. So this basically brings out the research that Professor Albert and his colleagues did and the comprehensive nature of the research, right? They looked at over 50 years worth of data, and they found that periods that were supposed to have benefited from cloud seeding, such as this 6-year period of increased rainfall, that was due to a cyclonic effect and not cloud seeding. So let's look at the questions. As used in line 8, practice most nearly meets. So this word, but research now reveals that the common practice of cloud seeding with materials such as silver oxide is not as effective. So the common procedure, practice here means the procedure of cloud seeding. So that's a good option. I can't use the word profession for cloud seeding. Profession is something that a person does for a living. So it's not B. It's not about background. I'm not looking at the background of anything or rehearsal, right? So the right answer is option A. The main purpose of the third paragraph of passage 1, lines 18 to 25. So yeah, this paragraph. So this basically brings out, as I said, the comprehensive nature of Professor Alpert's research. The research team used a comprehensive rainfall database and compared statistics of periods of seeding and non-seeding. So suggest that the extent of a problem has been exaggerated, gauge the success of an approach to an issue, detail the solution to a scientific puzzle, describe a methodology that led to a new understanding. So it's D, right? The methodology was that they looked at 50 years of climate data and rainfall data. And through such careful analysis, they came to the conclusion that cloud seeding is not as effective as has been hoped. Okay, the problem has not been exaggerated. In fact, the problem was not even identified until this data was looked at. So it's not A. You are looking at this approach to an issue, but this is not to gauge the success. This is rather to prove that the approach has failed. So it's not B. And this is not a solution to a puzzle. This is basically the methodology that led to a new understanding of cloud seeding. It can reasonably be inferred from passage 1 that an important reason for the conclusions reached by Albert and his colleagues was the presence of, and this is an evidence question, conditions that could reasonably account for an apparent increase in rainfall, the ongoing scarcity of rainfall in different and seemingly unrelated areas of the world, data available to allow comparison of rainfall in Israel with rainfall in other countries, a generally accepted account of cloud seeding over the past 50 years. So it's A, right? Because we know that Professor Albert said that this increase corresponded with a specific type of cyclone that is consistent with increased rainfall. So line 35 to 37, that is what is the evidence for this. The research did not involve other parts of the world. It was only focused on Israel. So B is wrong. It wasn't looking at other countries. So C is wrong. And it was actually trying to show that the generally accepted account was wrong. So D is wrong. So the answer is A. And yeah, the evidence, as we said, is in lines 32 to 37, because that's where we know that they came up with a reason for why rainfall had increased. So option D. Okay, which choice best supports the idea that the conclusions of the WWMPP? So this has to do with the second passage. So let's read the second one. Last year marked the conclusion of a massive 6-year study that has been the most comprehensive and rigorous to date to investigate whether cloud seeding actually increases precipitation, called the Wyoming Weather Modification Pilot Project, WWMPP. The study was run by a team of researchers from government, academia, and private industry. In the end, WWMPP wasn't able to provide a definitive answer, but the results do provide a body of evidence that cloud seeding is working under certain conditions, says Rolf Bruentes, an atmospheric scientist at the National Center for Atmospheric Research, who was not part of the project, although his colleagues at NCAR were deeply involved. Okay, so right off the bat, I notice a fundamental difference between the first passage and this one, in that this passage is a little more circumspect than the first passage with regards to the success of cloud seeding. It says that we do not know whether cloud seeding works, but it does seem to work in some cases. So this has definitely allowed for the possibility of cloud seeding to work in some cases, while the first passage was very categorical that cloud seeding does not work at all. Earlier studies would inject silver iodide into clouds, then compare precipitation gauges in areas inside and outside the seeding zone. But the studies weren't repeatable and they didn't include enough trials to guarantee that observed increases in precipitation weren't due to chance. The challenge with measuring the effect of weather modification is that natural rain and snowfall variability is 10 to 100 times as large as the amount of precipitation augmented by seeding, Bruentes says. So this paragraph focuses on the challenges of measuring the effects of cloud seeding, especially with regard to injecting silver iodide and then comparing rainfall in the seeded and the unseeded regions. It's very hard to say whether seeding had any effect because the snowfall and rainfall variability is many, many times larger than the amount of precipitation you get from seeding. Still, the WWMPP researchers thought they could address the drawbacks of past studies. The researchers designed their 14 million project to run for 6 winter seasons in the mountains of Wyoming. They conducted more than 150 tests, randomly selecting clouds to seed and clouds to be their unseeded controls. So another point of difference that you note from the Israeli study here is that the Israeli study only looked at data that was already available, while Bruentis and his colleagues under WWMPP created a new plan. They, in fact, wanted to better the studies that had been conducted in the past. And so they ran a $14 million project to study the effect of cloud seeding. Measurements from the high-resolution snow gauges on the ground indicated that seeding elevated snowfall by 5 to 15%, but this result was achieved only after the researchers threw out some of the tests where silver iodide drifted into controlled clouds or where not enough seeding material was released. So the final results weren't statistically significant. Nevertheless, all the results provided evidence for a positive trend. So this gives you the results of the survey. The survey said that there was an increase in rainfall by 5 to 15% in areas that were seeded. But because of uncontrolled factors, right, such as silver iodide drifting into the control clouds, etc., these results were not statistically significant. And so we could not say for sure whether seeding did have a positive effect. And yet Bruentis says that they indicate a positive trend. The scientists also took advantage of new developments in remote sensing and atmospheric modeling to examine dynamics inside a small subset of seeded clouds. Remote sensing observations are valuable because radar can describe growth of snow in a cloud in a much more immediate way than snow gauges can, says Bart Geertz, an atmospheric scientist at the University of Wyoming who was part of WWMPP. Detailed remote sensing measurements of cloud dynamics are cheaper and more doable than randomized statistical experiments that measure increases in snow on the ground, Geertz says. Okay, so this is another important aspect of the experiment and another point of difference with the Israeli experiment. Unlike the Israeli experiment that only looked at past data, this experiment involved new technological breakthroughs such as remote sensing. And this is important because remote sensing can more immediately measure changes in snowfall rather than the gauges that are put on the ground. And because remote sensing can more immediately measure these changes, it can also produce statistically significant results. So in many ways, the second study was more advanced, was more recent, was more detailed than anything done by the Israelis. And this study, therefore, leaves open the idea that cloud seeding does have a positive effect on precipitation. 25, which choice best supports the idea that the conclusions of the WWMPP cannot be regarded with complete confidence? Okay, so 44 to 47. 44 to 47, okay. 56 to 58. 56 to 58. 75 to 79, 91 to 94. 75 to 79 and 91 to 94. Okay. So the first option, called the Wyoming Weather Modification Pilot Project. The study was run by a team of researchers from government. So this only describes the makeup of the WMPP. It doesn't tell me that its results cannot be treated with confidence. Earlier studies would inject silver iodide into clouds, then compare precipitation gauges in areas inside and outside the seeding zone. So this talks about earlier studies. But this result was achieved only after the researchers threw out some of the tests where silver iodide drifted into controlled clouds or where not enough seeding material was released, or the final results weren't statistically significant. So this is the best option for how these results need to be taken with a pinch of salt. And detailed remote sensing measurements of cloud dynamics are cheaper and more doable than randomized statistical experiments that measure increases in snow on the ground. So this is one of the advantages of remote sensing. It doesn't really tell me about the results of WWMPP, so that's option C. 26, which choice best represents the different meanings of run as used in line 46 and line 68 respectively? Okay, so 46 run and 68 run. Okay, so called the WWMPP, the study was run by a team of researchers from government. So the study was conducted. So I'm looking at conducted here. The researchers designed their 14 million project to run for 6 winter seasons. That is to go on for 6 winter seasons, right? So I'm looking at conducted and continue, right? The study was run by a team, so it was conducted by a team, and the study was designed to run for 6 seasons, so to continue for 6 seasons. The study was supervised by a team. This is fine, but you can't complete something for 6 seasons, right? You only complete something when it's coming to the end. So this is wrong. It doesn't mean evade. The study was not evaded by a team. To evade is to kind of not get hold of something. For example, the thief evaded the police. So that doesn't make sense here. And I don't want to say the study was carried by a team, right? That's not the right meaning of carry. The study was conducted. That's the best answer. So C. The fifth paragraph of passage 2, lines 82 to 85, serves primarily to. So 82 to 85, this one. The scientists took advantage of new developments in remote sensing and atmospheric modeling to examine dynamics. So this introduces the idea of how their studies were perhaps somewhat better than previous studies because of their use of technological advancements. To highlight an advanced technique that improved the study, compare the effectiveness of older and newer approaches, explore the methods used to justify the cloud seeding, suggest that some key information may have been compromised. So it's A, right? This is to introduce the idea that an advanced technique was used so that the results obtained could be more precise. This paragraph doesn't compare the effectiveness, right? We know that the new technique would help obtain better results than older techniques, but that effectiveness is not compared here. The methods have been used to get more precise results, not necessarily to justify cloud seeding, right? If the more precise results come up and say that cloud seeding is absolutely ineffective, the researchers would be more than happy to publish the truth. So C kind of distorts the use of these new methods and suggests that some key information may have been compromised. No, absolutely not. In fact, they wanted to improve their results, and that is why they used these techniques. Which choice best describes the relationship between the two passages? Each passage explored an experiment addressing a certain problem, and these experiments have similar weaknesses. Each passage describes a research study about the same practice, but these studies yield different conclusions. Passage 1 provides a general discussion of an ongoing scientific puzzle considered more specifically in passage 2. Passage 1 explains the significance of a research finding that passage 2 argues as only a limited practical application. Okay, so let's try and eliminate some options. Option D is definitely out, because the first passage looks at research from the past 50 years, right? And the second passage considers its own study. So the first one doesn't explain the significance of a research that the second passage doesn't believe in. Each passage explored an experiment addressing a certain problem, and these experiments have similar weaknesses. This is definitely wrong, because we know for a fact that the second experiment, the experiment of the second passage, is far superior to the experiments that the first passage studied. Each passage describes a research study about the same practice, but these studies yield different conclusions. So this makes sense, right? Because the first and the second passage, they both look at cloud seeding. And the second passage has a more positive spin on the results, in the sense that the second passage leaves open the idea that cloud seeding does have positive effects on precipitation. The first passage says it does not, so I like B. Passage 1 provides a general discussion of an ongoing scientific puzzle considered more specifically in passage 2. So I don't like C because I don't think that passage 2 is more specific than passage 1, right? I think they are both very specific in their approach to cloud seeding. It's just that their research methodologies are different, right? But that does not mean that the second passage is more specific. So yeah, I think B is better. Okay, which choice best reflects the designs of the studies explored in passage 1 and passage 2 respectively? The researchers in passage 1 compared seeded and unseeded clouds, whereas the researchers in passage 2 only seeded clouds. The researchers in passage 1 considered a variety of environments, whereas the researchers in passage 2 focused on a single country. The researchers in passage 1 utilized readily available equipment, whereas the researchers in passage 2 relied on cutting-edge technology. The researchers in passage 1 analyzed a set of existing data, whereas the researchers in passage 2 conducted new experiments. So it's D, right? That's the fundamental difference between the two passages, that the first passage looked at data that was already available, while the second passage, the researchers went out and conducted their own experiments. Okay, the first option is not correct because both experiments, the first and the second, had control and experimental clouds. So A is wrong. The second one is not true because both experiments focused on one country. In the first case, it was Israel. In the second case, it was US. And the third one is not correct because the first passage researchers did not utilize any equipment, right? They only looked at data that was already available. So C is wrong. Compared to the way in which the author of passage 1 presents Alpert's study, the author of passage 2 presents the WWMPP as being less definitive in its approach, less flexible in its approach, more relevant in its approach, more abstract in its approach. So it's A, right? Because the second passage, as I said, is more circumspect about the effects of cloud seeding. It leaves open the idea that seeding benefits precipitation, while the first passage is quite certain in saying that it does not benefit precipitation. So the second passage is less definitive. I don't think flexibility is something that is approached in the passages. I think both passages looked at data. The first one looked at available data. The second one created its own data. So flexibility is not something that's here. Relevance is also something that's equally important to both passages. And there's no abstraction, right? This is a scientific experiment and both look at data and arrive at results. So there is no abstraction. So it's A. Okay, let's grade this from 21. ADADC, ADADC, CABDA, CABDA. Okay, great. So we got all correct. Hope this helped. If it did, hit like and subscribe to the channel. I'll link to the solutions of this test, the entire solutions with math and writing as well, in the description box. So do check those out. I'll see you in a new video soon. Take care. Bye-bye.